Question 11 is asking you to give the IUPAC name of some alkenes, those are hydrocarbons that have a double bond, and alkynes, those are hydrocarbons that have a triple bond. So in this particular example, there are no branches, and so we just need to find the prefix, the infix, and the suffix, and to say where the double bond is. So first, how many carbons? We have 1, 2, 3, 4 carbons. You might be able to see that a little more clearly on the left. 1, 2, 3, 4 carbons. The prefix for 4 carbons is bute, and so the prefix for this molecule is bute. You can see that we do have at least one double bond, and so the infix will be En. And last but not least, you can see that the molecule is just made up of hydrogen and carbon. You can see that really clearly on the Lewis structure, but if you look on the skeletal structure, you also can see that because no symbols for other elements are drawn in. So if you see a skeletal structure and there are no symbols for other elements, then you know it's just made of hydrogen and carbon. And so it's a hydrocarbon and the suffix is E. So this is going to be butene. Now we also have to say where the double bond is in butene. You could imagine it being on the ends, like it is here, or maybe in the middle of the molecule. So we have to say where exactly it is. And the first thing we're going to do for that is to number this chain. Now we can number it left to right or right to left. You want to number it so that the double bond gets the lowest number. So for example, if I number this left to right, I would have 1, 2, 3, 4, and the double bond starts at carbon number 1. If I number it right to left, I would have you would have 1, 2, 3, 4, and the double bond would start at carbon 3. So because you get a lower number in the green way of numbering, that's the way you number this molecule. So the double bond starts at carbon 1, and you'd put that 1 in front of the backbone name, the dash. There's always a dash between numbers and letters. And so the name for this molecule would be 1-butene. 1-butene. Alright, so for this molecule, now here we do have a branch. And so we want to see the longest carbon chain that we can find without going back or lifting up our pencil. So here we have 1, 2, 3, 4, 5, 6, 7. Or you could also imagine 1, 2, 3, 4, 5, 6, 7. So no matter how we number it, you have a parent chain of 7 carbons long. I'm going to number it in the green way. You could have also numbered it in the red way. And so let's point that out as our parent chain. I'm going to circle that so it really sticks out, separates it from the branches. And now let's try to name that parent chain as if there were no branches on it. Now we have 7 carbons, and because we have 7 carbons, the prefix is going to be hept. In that carbon chain, you can see that there's at least one triple bond, and so the infix is going to be YN. Last but not least, you can tell that it's only made of hydrogen and carbon. It's very clear in the Lewis structure, but remember you can see it in that skeletal structure because no symbols for other elements are written in. And so the suffix is E. Now, the backbone isn't just heptyne, because we have to say where that triple bond is located. So, we could number it in this green way, sort of from top to bottom. You could also imagine numbering, in which case the triple bond starts at carbon 2. You could also imagine it numbering it from bottom to top, so you'd have 1, 2, 3, 4, 5, 6, 7, and the triple bond would start at carbon 5. Since 2 is lower than 5, you would number it in the green way and not in the red way. So you would want to say where that triple bond starts, and that triple bond starts on carbon number 2, right here. So you'd put that 2 in front of the backbone name. Always between numbers and letters goes a dash, and the name for the backbone would be 2-heptyne. Now notice that it's more important to get a lower number for the triple bond than it is to get a lower number for the branch. If we had numbered it in the red way, the branch would have gotten a 2, and the double bond would have gotten a 5. But it's more important to give, or the triple bond, but it's more important to give the triple bond the lower number than it is to give the branch the lower number. So now that we've named the backbone 2-heptine, let's try to name that branch. The branch is coming off of carbon number 6. Always in between numbers and letters goes a dash. In this carbon, there's one carbon in it. In that chain, there's one carbon. So the prefix is meth. And because it's a branch, immediately after that prefix comes YL. So 6-methyl. You can take the branch name, it always goes in front of the backbone name. Oops. Let's put that down here. So we'll put that in front of the backbone name, and that would be the full name. So we'll have 6-methyl-2-heptine. Always between numbers and letters goes a dash, and so this would be the IUPAC name for this molecule. Alright, let's try this one. Now the first thing you might notice here is that you don't have any branches, so we don't have to worry about finding a backbone. There's only one carbon chain, and also that it's in a ring. Now if a molecule ever goes in a ring, you put the prefix cyclo. Next, we need to know how many carbons there are, and so you can start numbering at either of the ends of the double bond. Just remember you have to cross to the next carbon in the double bond when you number. And going around, you can see that there are 5 carbons in this ring. And the prefix for 5 carbons is pent. So cyclopent. Now you can also notice that there is at least one double bond in this ring, and so the infix is En. Last but not least, notice that it's just made of hydrogen and carbon, and so the suffix is E. Now, no matter where you put the double bond in this molecule, it's the same. Let me give you some examples. Let's say we put the double bond here, or here, or here. At first glance, those might look like different molecules, but remember that these are 3-dimensional things that can move around in space. And so if you were to rotate that just a little bit, you'd end up with this second ring there. And if you were to rotate that ring a little clockwise, you would end up with the third ring. And so you can see that no matter where you put the double bond, it's all the same molecule. And because of that, it's not necessary to put a number for the double bond. No matter where you put it, the molecule is the same. And so technically, the IUPAC name for this would be cyclopentene. However, there are some professors who are more lenient, and if you wanted to put a number where the double bond started, even if it is redundant, they wouldn't take points off. So you should consult your specific professor when naming molecules like that. So you could imagine the IUPAC name for this molecule being either 1-cyclopentene if you had a more lenient professor, or just cyclopentene if you had a more rigorous professor. Okay, now this one is asking you to give the IUPAC name for this molecule, and there are no branches on this. So our first order of business is to find the number of carbons in this chain. Now, if you number it, you would find that there are 5 carbons, and so the prefix is pent. Notice that there's at least one double bond, and so the infix is En. Finally, there is only hydrogen and carbon in the molecule, so the suffix is E. Now, we do have to say where the double bond attaches, or where the double bond is inserted into this. And you can imagine numbering this chain in 2 ways. You can number it left to right, in which case the double bond would start on carbon 3, or you could imagine numbering it right to left, in which case the double bond would start at carbon 2. Since numbering it right to left gives a lower number to the double bond, we're going to number it right to left and go with the green way of numbering. So here you'd have 2, always between numbers and letters goes a dash, pentene. The IUPAC name for this molecule would be 2-pentene.